Bluetooth. So, Bluetooth is basically a network which we were using to share files between phone to phone or some for laptop to laptop. We were using a lot of techniques. Now also we use it presently. So it was a basic mode of exchanging files between two phones or two medias. So how was it working? Have you ever wondered how Bluetooth worked? No, because we were all busy sending files to each other. So basically, a Bluetooth has two. Basically, a piconet is what is, there'll be one primary source, okay, and there'll be a lot of secondaries. Okay, this is the primary, this is secondaries, a lot of secondaries. Okay, so there is a connection between a primary to secondary, just like one of the network layers diagram, right? So here in a piconet, this is called a piconet, the whole thing, this full network is called a piconet. One piconet can have 8 stations in total including the primary. So that means one primary means it can support up to 7 secondaries in it. That's all it can support. This is a piconet network where it supports only 8 devices in a one network, and there will be one primary source and a primary secondary. 7 devices can be supported in it. Okay, so the device communication between the primary and the secondary is in the next topic that I am going to explain, but presently you just know what is a piconet. A scatter net is almost similar to a piconet, but there is a little more extension to it. There is a twist. What does that means? There will be one primary, lot of secondaries under it. This is one piconet. Okay, this is one piconet, and there will be another primary in between. Yes, and there will be a secondary here. So here this primary is acting also as a secondary, and this primary can communicate with this, and this is under the network of this. So it's a bridge. This is acting as a bridge between these two systems. So this is called a scatter net. The whole thing is called a scatter net. There is no limitation that only these many devices will be supported or nothing like that. Only in a piconet, same way, it's an extension to it. So this is basically the two types of networks that the Bluetooth uses to share the files between two files. So what are the layers that are there in a Bluetooth? So we have a number of layers in a Bluetooth. One is called a radio layer, then a baseband layer, then we have a L2 cap layer, which is not much important, and these are the three main layers of a Bluetooth. So taking the first layer, that is the radio layer, first into the picture. Okay, so what does a radio layer represents? You know, Bluetooth is a short range device. We use Bluetooth devices on a years. We know that it can be activated only for a range of 10 meters. It is a very low powered one, and its range is only 10 meters. So this layer is representing that how much range can a Bluetooth range up to. So what is the band of the Bluetooth? How much bands can the Bluetooth support? It can support only about 2.4 gigahertz. Maybe the technology has advanced right now, but basically the basic version was supporting up to 2.4 gigahertz band, and that channel was divided into 79 channels, each of 1 megahertz. Get it? So 2.4 gigahertz channels divided into 79 channels, each one of 1 megahertz each. So again, this layer was using a special technique. It was a very special technique that is called FHSS. Yes, it's called a frequency hopping spread spectrum. So what is this for? We know that when we are sending a file from one device to another device cannot interfere in between it, right? Only two devices can communicate with each other. So that interference of another device entering into the network is controlled by the frequency hopping spread spectrum. This avoids the interference of another device getting into the network. Only two devices if they are communicating with each other. So that is the special technique that the radio layer contains right now. So we know that the data is represented in bits, right? So how can I transfer the bits from one device to another? That's a question. So for this question to be answered, for one device to communicate with another device, we use signals, right? It's basic thing. Only if there is a signal passing from one device to another, two devices can communicate with each other, right? So how do you convert these bits to signals? So again, the radio layer comes into picture. Radio layer has another important one, which is using a sophisticated, or to be telling a complicated version of something called FSK, which is called GFSK. It's called Gaussian FSK. The full form is not revealed, but I'm not sure of the full form FSK. But G stands for Gaussian. I know that. So what is this GFSK? How do I convert the bits into signals? Basically, GFSK is actually a carrier frequency. GFSK is actually a carrier frequency. Now, what does this carrier frequency mean? It means that the bit 1, the first bit, how is it represented? Imagine there is an axis called carrier. Okay, the bit 1 will be represented by the frequency modulation above the carrier. This is the bit 1. Okay, and the bit 0 is represented by a frequency deviation below the carrier. So this is how the bit 1 and bit 0 are represented as a waveform. So GFSK is a carrier frequency. Assume that the carrier is like an axis. Don't just tell that, but actually we are assuming that carrier may be a axis. So bit 1 will be represented by a frequency deviation above the carrier, and bit 0 is represented by the deviation below the carrier. So this is how we convert the bits into signals. You get it? So how do I find out the frequency of each and every channel that has been created right now? So for that we have another formula called FC. Frequency for each channel is equal to 2402 plus n. Okay, n can range from 0 to 78, because I have already told you that 2.4 gigahertz is divided into 79 channels, each of 1 megahertz of strength. Yeah, right. So it can range from 0 to 79. So each value you add to it, if you substitute n by 0, it becomes FC is measured in megahertz. Okay, megahertz. So if you add 0 to it, it becomes 2402 plus 0, which is 2402 itself, megahertz, which can be converted into gigahertz as 2.402 gigahertz. Similarly, you go on adding like that, only reciprocating like this, you get a series after this. So the 2.4 number stays constant. After that, beyond that, numbers goes on increasing, right? So all are represented as gigahertz. This is what is specified here. That is the band of the Bluetooth that it supports. Everything is in the same band, 2.4 gigahertz band itself. So this is the basically a Bluetooth. What is the architecture of the Bluetooth, and what are the layers that are supported by the Bluetooth? Actually, I'll post another video on baseband layer, because baseband layer is more related to how does a primary device is communicating with another device, secondary device. So it needs a little more concentration towards the topic, and it's elaborated more. So that's all for now, guys. This is the Bluetooth we were using from a longer point of time. This is the architecture of the Bluetooth, two networks that we are using, and then these are the layers of the Bluetooth. Sorry, I forgot to write the name of it. So this is the radio layer, maybe it's visible, baseband layer, and then L2 cap layer. Okay, L2 cap layer is not much important. Yeah, sure. So this is the radio layer, and then what is the band supported by it, how is it divided into. Then we have FHSS, which is removing the interference by the other devices. And how will you convert from bits to signals? It's from a technique called GFSK, which is the carrier frequency. Bit 1 is represented above the carrier, bit 0 is represented below the carrier. And how do you calculate the frequency for each and every channel? It's related from FC, which generalizes our topic here. So thank you for viewing this video, and subscribe for this channel for more further educational videos on such topics. I'll post another video on baseband layer as soon as possible. Thank you.